In Peoria, Illinois, there is a factory that Caterpillar drives past every single day. Inside that factory, workers build the best-selling mining truck on the planet. It weighs 320 tons. It runs on electric wheel motors. Every single one of them rolls off the same factory floor that a 6th grade dropout built in 1935. The factory does not belong to Caterpillar. It belongs to Komatsu, their biggest competitor. The technology inside those electric wheels was patented by a man Caterpillar once told to go away. That man was R.G. LeTourneau. The machine Caterpillar does not want you to know about is not a single truck or a single loader. It is an idea. An electric wheel motor, filed as United States Patent 2726726 on August 23, 1950. Caterpillar had already rejected the concept 13 years earlier. LeTourneau built it without them. Today, every ultra-class mining truck operating in every copper mine, every coal mine, and every iron ore pit on Earth runs on direct descendants of that patent, including Caterpillar's own trucks. This is the story of how one company rejected the future, spent 74 years catching up, and ended up watching their biggest competitor build that future in the factory they helped create. We spent a long time researching this one, and what we found goes deeper than anything we expected. Here is the full story. Robert Gilmore LeTourneau was born in Richford, Vermont in 1888 and dropped out of school after the 6th grade. He never completed an engineering course. He never earned a degree. In 1906, at the age of 14, he survived the San Francisco earthquake. That experience shaped something in him. He did not talk much about it later, but the scale of destruction, the entire city flattened, seems to have planted the idea that machines could be built big enough to reshape the landscape itself. For the next 14 years, LeTourneau bounced between odd jobs: iron worker, bricklayer, ranch hand. He was not successful at any of them. By his own account, he went nearly broke multiple times before he turned 30. In 1920, at age 32, he scraped together enough money to buy a used 1915 Holt 75 crawler tractor for $1,000 and started a land leveling business in Stockton, California. The tractor was second-hand. The scraper he pulled behind it was homemade. And this is where the LeTourneau story takes its first turn. The equipment he could buy was not good enough for the jobs he was taking. The scrapers on the market were too small. The blades were too weak. The cable controls were too crude. So LeTourneau, the man with no engineering education, started building his own. For the next 9 years, he designed and welded attachments in a small shop behind his house. Bulldozer blades, cable rippers, pull scrapers, sheepfoot rollers. He was not building machines for other people yet. He was building them for himself, because nothing on the market could do what he needed. His key invention during this period was the power control unit, a double-drum cable winch driven directly from the tractor's power takeoff. It was crude. It was brutal on the operator's hands, but it allowed a single man on a Caterpillar tractor to control a bulldozer blade or a scraper bowl with cable tension instead of brute muscle. We covered how that cable technology transformed the construction industry on this channel. And the numbers are staggering when you realize how much of the world was literally shaped by these systems. LeTourneau filed his first patent in 1923. United States Patent 1,470,853 for a self-propelled scraper. Over the course of his lifetime, he would file 299 patents total, not 300, as some sources claim. 299, each one documented in the archives at LeTourneau University in Longview, Texas. That changed in 1929, when Caterpillar started buying his attachments. The arrangement was simple. LeTourneau built the blades, the rippers, the scrapers, and the rollers. Caterpillar built the tractors. Contractors bought both. And within a few years, R.G. LeTourneau's company had become the single largest supplier of earth-moving attachments to the Caterpillar Tractor Company. Every time a Caterpillar tractor pushed dirt in the early 1930s, the blade on the front, the ripper on the back, or the scraper it was pulling almost certainly came from LeTourneau's shop. The relationship was not an equal partnership. Caterpillar was the giant. They had been formed in 1925 from the merger of Holt Manufacturing and C.L. Best Tractor Company. We covered both of those stories on this channel. Benjamin Holt invented the crawler track in 1904. C.L. Best watched his father sell the family business to Holt for $325,000, then spent the next 16 years fighting to get it back. When the two companies merged, it was Best's tractors, not Holt's, that became the foundation of the Caterpillar line. The Caterpillar 60 was a Best 60 track layer with a new name. The Caterpillar 30 was a Best 30 with a new paint job. By 1935, Caterpillar was a major corporation headquartered in Peoria, Illinois. LeTourneau was still a small manufacturer in Stockton, California, but Caterpillar recognized his value. They invited LeTourneau to move his manufacturing operation to Peoria, right next to Caterpillar's own headquarters. LeTourneau accepted. He built a plant at 2300 Northeast Adams Street, and he opened it the way he opened everything, with a prayer service. LeTourneau was deeply religious throughout his life. He gave 90% of his income to Christian ministries and kept 10% for himself. He called himself God's businessman and said the Lord was his senior partner. For 2 years, the partnership worked. LeTourneau made the attachments. Caterpillar made the tractors. Contractors bought both and moved the earth. The cable control systems that connected LeTourneau's blades and scrapers to Caterpillar tractors were the backbone of every major earth-moving project in America. We covered how that cable technology transformed the entire construction industry on this channel, and the numbers are staggering when you realize how much of the world was literally shaped by these machines. Like and subscribe so you do not miss any of these stories. Then, in 1937, everything changed. LeTourneau was driving near his plant when a car accident put him in a full body cast for 6 months. He could not walk. He could not visit the factory floor. But he could think, and he could draw. Lying flat on his back, LeTourneau designed something entirely new. A self-propelled, rubber-tired, 2-wheeled prime mover that could pull his carryall scrapers at 20 miles per hour without needing a Caterpillar tractor at all. He called it the Tournapull. When he recovered, he brought the design to Caterpillar management in Peoria and laid it out on the table. Their response was 2 words: not feasible. Caterpillar looked at a rubber-tired scraper and saw a threat to their tractor business, not an opportunity. They were selling tractors. LeTourneau was proposing to eliminate the need for them. LeTourneau's own response, recorded in his autobiography, was blunt. Called crazy again, he knew he was on the right track. His exact words, written years later, put the rejection into perspective. He pointed out that his competitors included giants like Caterpillar, General Motors, International Harvester, Alice Chalmers, and 8 others, all big corporations with high-powered executive staffs and engineering departments. And in the middle of all of them, he was the hick from the backwoods. But during World War II, it was his organization that built over 50% of the earth-moving equipment used in combat. And the machines that did the job were what his competitors had declared to be some of that crazy LeTourneau stuff, right up to the outbreak of hostilities. He was not exaggerating. The Model A Tournapull was unveiled in April 1938, powered by a 160-horsepower Caterpillar D, 17,000 VV8 diesel engine. Caterpillar's own engine was now propelling the machine they had told him could not work. The first 10 Model A1 units went to Guy F. Atkinson Company for the Hansen Dam project in Los Angeles. 13 million cubic yards of earth. The first major earth-moving project in history, done primarily by motor scrapers instead of crawler tractors. The Hansen Dam job proved everything. Rubber-tired scrapers loaded faster, hauled faster, and covered more ground per shift than any crawler tractor and scraper combination in existence. A Tournapull could travel at 20 miles per hour on a haul road. A Caterpillar tractor pulling a LeTourneau carryall topped out at 5 or 6 miles per hour. The math was brutal for Caterpillar. One Tournapull could move more earth per hour than 3 tractor scraper sets working together. According to construction historian Richard Campbell, it took Caterpillar almost 11 years to catch up to LeTourneau. And during those 11 years, LeTourneau was not standing still. By 1940, LeTourneau had expanded his Model A into a full product line. There was the Model B with a larger bowl, the Model C with a longer wheelbase, the Model D with a heavier frame for rock work. Each one was self-propelled. Each one eliminated the need for a Caterpillar tractor. And each one was selling faster than LeTourneau could build them. And then the war came. Between 1941 and 1945, LeTourneau's factories in Peoria, Toccoa, and Vicksburg produced earth-moving equipment at a pace no one had ever seen before. 14,000 bulldozer blades, 10,000 carryall scrapers, 1,800 Tournapulls, 1,600 sheepfoot rollers, 1,200 rooters. The United States Army, Navy, and Marines used LeTourneau equipment to build airfields across the Pacific, carve roads through the jungles of Burma, and prepare the invasion beaches of Normandy. The scale of that production is difficult to comprehend. In the Pacific Theater alone, the Navy Seabees used LeTourneau bulldozer blades to clear coral and jungle for over 100 airfields on islands most Americans had never heard of. The Burma Road, carved through some of the most hostile terrain on Earth, was graded and maintained by LeTourneau motor scrapers. When the Allied forces landed at Omaha Beach on June 6, 1944, armored bulldozers fitted with LeTourneau blades were among the first machines ashore, pushing debris, filling craters, and clearing paths for tanks and trucks under direct enemy fire. Several of those operators were killed in the first hours of the invasion, crushed inside open cabs, while German machine gun rounds struck the blade and the cab frame around them. 70%. That is the number the Historical Construction Equipment Association cites for LeTourneau's share of all Allied earth-moving equipment during the war. A single company, run by a 6th-grade dropout, outproduced every major equipment manufacturer in the United States combined. We told R.G. LeTourneau's full life story on this channel, and his wartime production alone would make him one of the most important figures in American industrial history. The war made LeTourneau rich. More importantly, it proved to every military commander and every civilian contractor on Earth that rubber-tired, self-propelled earth-moving equipment was the future. The crawler tractor would not disappear. Caterpillar's D8 and D7 bulldozers were critical throughout the war, but the Tournapull, the carryall, and the motor scraper had proven they could move more dirt faster and over longer distances than any tracked machine ever built. But the war production is not what Caterpillar does not want you to know about. The scrapers, the blades, the Tournapulls, those are well documented. What comes next is the part that changed the entire mining industry forever. And Caterpillar was not even in the room when it happened. LeTourneau had been thinking about electric drive since 1923. His very first self-propelled scraper used a gasoline generator powering 7 distributed electric motors. It worked, barely, topping out at 1 mile per hour because electrical components in the 1920s could not handle the loads. He shelved the idea, but he never forgot it. In 1944, he revisited the concept. By 1948, he had mounted electric motors directly on the axle housings of an experimental wheeldozer called the Model D electric tornadozer. The motors worked. The power was there. But the breakthrough was not the motor itself. General Electric and Westinghouse had been building electric mine locomotives for decades. The breakthrough was packaging an entire drive system inside a single wheel. Each wheel became a self-contained unit. An electric motor, a planetary gear reducer, and a brake assembly, all enclosed in a single housing. The wheel was the motor. The motor was the wheel. The system eliminated drive shafts entirely. It eliminated transmissions. It eliminated differentials. Every wheel had independent torque control. On August 23, 1950, LeTourneau filed the patent, United States Patent 2726726, titled Electric Vehicle Wheel. 4 claims described helical reduction gearing inside a hollow shaft, with the motor housing functioning as a stationary axle. The architecture he described in those 4 patent claims is exactly the architecture that powers every ultra-class mining truck on Earth today. The patent was filed as serial number 181,038, with the assignee listed as R.G. LeTourneau, Inc., Peoria, Illinois, a corporation of California. It was granted on December 13, 1955. But here is the detail that makes this story extraordinary. The patent was filed 3 years before LeTourneau sold his Peoria business to Westinghouse Air Brake. It was granted 2 years after the sale, and LeTourneau never reassigned this patent to the new company. On May 1, 1953, the LeTourneau Westinghouse Company was incorporated. The sale price was $31 million. Some sources, including Peoria Magazine, cite $25 million, but the authoritative figure from LeTourneau University and Eric Orlemann's official company biography is $31 million. Westinghouse Air Brake was flush with cash from George Westinghouse's railroad air brake monopoly, but they could see that business was declining. They wanted into construction equipment. LeTourneau wanted capital to pursue his electric wheel experiments. Westinghouse got the Peoria plant, the Toccoa plant in Georgia, the Rydalmere plant in Australia, the current product line, all inventory, and a 5-year non-compete clause in earth-moving equipment. The Colorado Supreme Court case, Colorado Builders Supply versus Hinman Brothers Construction, decided December 10, 1956, is the primary legal record of the deal terms, including the indemnification language, where Westinghouse agreed to assume all liabilities accruing on and after May 1, 1953. R.G. LeTourneau kept the Vicksburg, Mississippi plant. He kept the Longview, Texas plant, and he kept the electric wheel patent. The deal was structured so that Westinghouse bought the mechanical drive, earth-moving business, everything powered by diesel engines, cable controls, drive shafts, and transmissions. LeTourneau kept the electric future. It is one of the shrewdest deals in American industrial history. Westinghouse thought they were buying the whole company. What they actually bought was the past. LeTourneau walked away with the 2 plants he needed to build electric machines and the 1 patent that would define the next 70 years of the mining industry. The non-compete expired in 1958. LeTourneau was 70 years old. Most men at 70 slow down. LeTourneau did the opposite. He came back swinging, and every single machine he built from 1958 onward used electric wheel drive. Every one. The machines he created in those final 11 years of his life look like science fiction compared to anything Caterpillar was building at the time. Before the Snow Freighter, there was the Snow Buggy, a military prototype completed in June 1954 for testing in Greenland. 8 10-foot Firestone tires, 4 hub motors, a single Allison V1710 V12 engine, the same engine that powered a P-38 Lightning fighter aircraft, running on butane. The machine was enormous, and its tires would go on to have a second life that nobody saw coming. In the 1980s, a man named Bob Chandler bought 4 of those original LeTourneau snow buggy tires from a Seattle junkyard for $1,000 and mounted them on Bigfoot 4 and Bigfoot V. The electric wheel tires that LeTourneau designed for Arctic warfare literally became the foundation of monster trucking. The VC-22 snow freighter, built in 1955 for Alfred Getze Jr.'s Alaska Freight Lines under a $450,000 contract, was 274 feet long with 24 wheels, every single one driven by its own electric motor. 2 Cummins V12 diesels, totaling 800 horsepower, generated the electricity. It operated at temperatures down to negative 68 degrees Fahrenheit. It could ford 4 feet of water. The snow freighter made one successful run across the frozen Alaskan interior. On the second run, it jackknifed and burned. Alaska Freight Lines lost $1 million. The rusting hulk still sits along the Steese Highway near Fox, Alaska, slowly being consumed by the boreal forest. The machine failed, but the electric wheels did not. They worked perfectly in conditions that would have destroyed any mechanical drivetrain on the market. Then came the TC-497 Overland Train Mark II, delivered to the United States Army at Yuma Proving Ground in February 1962. The longest off-road vehicle ever built, a confirmed Guinness World Record that still stands today. 572 feet long, 54 wheels, all electric drive. 4 solar Tense MC gas turbines producing a total of 4,680 horsepower. Each turbine drove a generator that fed electricity to the wheel motors through an independent circuit. If one turbine failed, the others kept the train moving. LeTourneau publicly stated the turbines were a stopgap until atomic power could be installed. He was not joking. The United States Army was genuinely exploring nuclear-powered land vehicles in the late 1950s, and LeTourneau designed the Overland train's power bay to be swappable. The Army tested it under Project Otter, short for Overland Train Terrain Evaluation Research. The concept was simple. In the Arctic, where there were no roads and no railroads, the only way to supply a forward base was by air. Air supply was expensive and weather-dependent. An overland train that could haul 500 tons of cargo across tundra, muskeg, and frozen rivers would change Arctic logistics forever. The overland train worked. It crossed terrain that would have stopped any wheeled or tracked vehicle in the Army's inventory. But the Sikorsky CH-54 Tarhe heavy-lift helicopter made overland trains obsolete before they ever reached production. The helicopter could carry loads directly, without roads, without bridges, without worrying about river crossings or ground pressure. The Army canceled the program. The overland train was parked in the Arizona desert. Only the control cab survives today, on display at the Yuma Proving Ground Heritage Center. Like and subscribe to follow this story. And then there was the Scorpion, christened March 20th, 1956 in Galveston, Texas, the first 3-legged self-elevating jack-up offshore drilling rig ever built, the design that now drills more than half the world's offshore oil. The customer was Zapata Offshore Company. The president of Zapata was a young oil man from West Texas named George Herbert Walker Bush. Bush advanced $400,000, then paid $550,000 plus 38,000 shares of Zapata common stock when the rig performed. Bush later wrote about LeTourneau in his autobiography, describing him as gruff, eccentric, a kind of George Patton of engineering. When the Scorpion's jacking system failed during testing, Bush watched the 67-year-old LeTourneau pull a piece of chalk from his pocket and draw the redesign directly on the deck plate. No engineering drawings, no slide rule. It worked. The largest machine LeTourneau ever built was the pacemaker LT360. It had three 72 cubic yard scraper bowls in tandem, 200 feet long, 19 feet wide, 8 60-inch electric wheels, 8 Detroit diesel 16 V71N engines, totaling 5,080 horsepower. It was the largest scraper ever built. 0 were sold. The electric digger proved the technology could handle anything, but it exceeded what the market was willing to buy. And then there was the machine that still holds a Guinness World Record today. The L2350 wheel loader, unveiled at the 2000 World Mine Expo in Las Vegas. Operating weight of 587,800 pounds. A 53 cubic yard bucket. Diesel-electric drive with 4 independent traction motors. Tires 13 feet tall, each weighing 7 tons, each costing roughly $60,000. Built in Longview, Texas. The plant LeTourneau kept in 1953. R.G. LeTourneau died on June 1, 1969. He was 80 years old. He held 299 patents. He had given 90% of his income to charity throughout his career. He left behind a university in Longview that still bears his name. He never saw what happened to the factory he built in Peoria. After the 1953 sale, Westinghouse did something smart with the Peoria plant. They hired an engineer named Ralph Kress in 1955 and tasked him with designing a new truck line. Kress was a brilliant truck designer, and the machine he created would launch an entirely new product category. In 1957, the first haul-pack truck rolled out of the Peoria factory and led the Thanksgiving Day parade through downtown Peoria on its way to the Midland Mine. 32 tons. Mechanical drive. It was a good truck. The haul-pack name became so dominant in mining that contractors used it as a generic term, the way people say Kleenex instead of tissue. By 1967, the LeTourneau Westinghouse name was gone, replaced by WIBCO. The connection to R.G. LeTourneau faded from corporate memory. New management, new branding, new identity. But the Peoria factory floor was the same one LeTourneau had built, and the trucks rolling off it carried his engineering DNA in their frames and their axle housings, even as the company forgot his name. In 1968, American Standard won control of WABCO after a bitter, litigious battle with Crane Company that made headlines in the business press. American Standard was a conglomerate that made plumbing fixtures, heating systems, and industrial brakes. They had no particular expertise in mining trucks. And it showed. Under American Standard ownership, WABCO's market position gradually eroded. Then in June of 1984, American Standard sold the WABCO construction and mining equipment division to Dresser Industries for $66.3 million and took a $22 million write-down on the deal. Dresser was a Dallas-based oil services company. They knew heavy equipment. They knew mining. But they also knew they needed a global partner. In September of 1988, Komatsu and Dresser formed a 50-50 joint venture called Komatsu Dresser Company. The Japanese manufacturer brought engineering depth and global distribution. Dresser brought the Peoria plant and the haul-pack truck line. In August 1994, Komatsu bought out Dresser's share and took full ownership. The haul-pack name was quietly retired in 1999. R.G. LeTourneau's factory now belonged entirely to a company headquartered in Tokyo. And in 1995, the Komatsu 930E rolled off the production line at 2300 Northeast Adams Street, Peoria, Illinois. The same address where LeTourneau had opened his factory with a prayer service 60 years earlier. The 930E was the first ultra-class haul truck to exceed 300 tons. It was the first to use 2 alternating current traction motors instead of direct current. It used the exact architecture LeTourneau had described in patent 2,726,000 726 independent electric wheel motors with planetary reduction. Over 1,900 Komatsu 930E trucks have been sold since 1995, more than any other ultra-class mining truck in history. The world's dominant mining vehicle is built in LeTourneau's factory, and Caterpillar's headquarters is a short drive away. Like and subscribe for more stories like this. While all of this was happening in Peoria, Caterpillar was on the longest detour in heavy equipment history. They did not build their first off-highway truck until 1962, the Cat 769 at 35 tons. Euclid had been building off-highway trucks since 1933. Caterpillar was already 30 years behind. We told the full story of how Euclid dominated the dump truck market, and then General Motors destroyed them. And the parallels to the LeTourneau story are impossible to miss. Both Euclid and LeTourneau pioneered rubber-tired earth-moving technology that Caterpillar initially dismissed. Both proved the technology worked through raw market performance. In both cases, Caterpillar eventually entered the market late and tried to catch up through sheer corporate scale. Caterpillar built bigger trucks through the 1970s, the 1980s, and the 1990s. The Cat 707 appeared in 1974 at 85 tons. The Cat 793 arrived in 1991 at 240 tons. All mechanical drive, every single one. Mechanical drivetrains, with their planetary power shift transmissions and torque converters and drive shafts, were the engineering orthodoxy. Their argument was reliability. Mechanical components were simpler. Electric motors added complexity. And in the short-haul distances typical of some mining operations, mechanical drive was efficient enough. The problem was that mining trucks kept getting bigger. The bigger they got, the harder it became to build a mechanical drivetrain that could handle the loads. A transmission rated for 200 tons is an engineering marvel. A transmission rated for 350 tons is an engineering impossibility. Electric drive had no such limit. Each wheel motor was independent. Adding capacity meant adding wheels, not redesigning the entire drivetrain. In 1997, Caterpillar's internal engineering team considered a diesel-electric powertrain for their new flagship truck, the Cat 797. They chose mechanical drive instead, stating that a mechanical powertrain was more appropriate for market conditions at that time. That sentence, preserved in corporate records, is the most strategic and costly decision in Caterpillar's history. 1 year later, the Komatsu 930E was already running in copper mines across Arizona. Liebherr launched the T282 with Siemens electric drives at 330 tons. Caterpillar unveiled the Cat 797 in September 1998 at their Arizona proving grounds, 360 tons, 3,400 horsepower from a 24-cylinder Cat 3524B engine. Mechanical drive. Caterpillar clung to mechanical drive for another 13 years. At the 2008 Mayan Expo trade show in Las Vegas, Caterpillar's own marketing materials contained what amounted to a corporate confession. They acknowledged that in the late 1960s, Caterpillar was one of the first manufacturers to commercialize electric drive trucks, but they had elected to focus on mechanical drive instead. Cat Global Mining President Chris Kerfman stood at the podium and announced that Caterpillar would produce mining trucks for every application: uphill, downhill, flat or extreme conditions, and now with electric as well as mechanical drive. The word "now" did a lot of heavy lifting in that sentence. The technology had been available for 60 years. LeTourneau had filed the patent in 1950. Caterpillar had it in the late 1960s by their own admission, and they were just now getting around to offering it. The Cat 795F AC finally shipped in 2011. Caterpillar's first production electric drive mining truck. It used AC traction wheel motors with planetary reduction. the same fundamental technology LeTourneau had patented 61 years earlier. The same architecture the Komatsu 930E had been using in production since 1995. It arrived 42 years after LeTourneau died. The irony is hard to overstate. 16 years after the Komatsu 930E had already proven the concept in LeTourneau's own factory, Caterpillar's marketing language still reveals the tension. Their website still states that Cat mechanical drive trucks are the standard of the industry and are favored in most applications. It also notes that some customers prefer electric drive for specific applications and situations. That carefully worded hedging tells you everything about how deeply mechanical drive is embedded in Caterpillar's corporate identity. They adopted electric drive, but they still cannot bring themselves to call it the future. And then Caterpillar made one more move that ties the entire story together. In November 2010, Cat CEO Doug Oberhelman announced the acquisition of Bucyrus International for $8.8 billion. We covered the full rise and fall of Bucyrus Erie on this channel, and that story connects directly to this one. Caterpillar paid a 32% premium at $92 per share. Bucyrus CEO Tim Sullivan walked away with a severance package valued at over $45 million. Caterpillar got electric rope shovels, walking drag lines, and mining trucks. They also got the Marion Power Shovel brand, which Bucyrus had acquired in 1997 for $40 million. That meant Caterpillar now, incidentally, owned the intellectual property of the company that built the NASA crawler transporters, the machines that carried every Apollo rocket and every space shuttle to the launch pad. The South Milwaukee plant, where Bucyrus had operated for 123 years, was gutted within 5 years. There were 300 layoffs in March 2013, 260 more later that year, 60 more in 2014. Main plant production ceased in 2016. A century of manufacturing heritage gone. Oberhelman publicly conceded that Caterpillar probably paid too much. He was forced out as CEO that same year. By 2022, Caterpillar was giving away the underground mining intellectual property it had bought from Bucyrus, licensing the longwall technology to Hauhinco in Germany and the room and pillar line to Simmons Equipment in Virginia. But here is the ending that makes this entire documentary worth watching. In June 2011, Joy Global completed a $1.1 billion acquisition of LeTourneau Technologies from Rowan Companies. They got the Longview, Texas plant. They got the LUS 2350 wheel loader. They got the electric wheel technology. On April 5, 2017, Komatsu completed a $3.7 billion acquisition of Joy Global and renamed it Komatsu Mining Corporation. Add up what that means. The Peoria plant that LeTourneau built in 1935 and sold to Westinghouse in 1953 is now owned by Komatsu. It builds the 930E electric mining truck. The Longview plant that LeTourneau kept in 1953 and used to build his post-retirement electric machines is now also owned by Komatsu. It builds the L2350 wheel loader, sold today as the Komatsu WE2350. Both halves of R.G. LeTourneau's life work are now owned by Komatsu, Caterpillar's biggest mining competitor. Both plants build electric drive machines descended from patent 2726726. Caterpillar rejected the Tournapull in 1937. They ignored the electric wheel for 40 years. They chose mechanical drive over electric in 1997. They finally adopted electric drive in 2011, and they have spent the entire 21st century chasing a Japanese company that builds R.G. LeTourneau's machines in R.G. LeTourneau's factories. This is one of the most overlooked stories in the history of heavy equipment. A man with no engineering degree filed a patent that defines modern mining. The biggest equipment corporation on Earth rejected it. And 74 years later, that corporation is still running behind the idea they called not feasible. LeTourneau never saw the 930E. He never saw the 795 FAC. He never saw Caterpillar admit, in careful corporate language, that they had been wrong since 1937. But every time a Komatsu 930E rolls down a haul road in Chile or Australia or Wyoming, every time a Cat 795 FAC turns its wheels in a copper mine, they are running on the technology of a 6th grade dropout who Caterpillar called crazy. He filed the patent. He kept the patent. And 74 years later, the entire industry is still running on it. Like and subscribe for more stories about the machines and the people who built the world.